Hey everybody, this is Larry. This is me going over Q3 of the recent weekly contest 207. Hit the like button, hit the subscribe button, join me on Discord, and let me know what you think about this problem. Maximum non-negative product in a matrix. So for this problem, I would recommend, so there are a couple of problems in the last couple of contests where it's just you give it an array instead of a matrix. And the key thing to notice is that you can remove right or down. So basically, you're constructing different paths but different arrays. So if you weren't able to solve this, I recommend going over the maximum non-negative product in an array and then understanding that solution, and it will help you with the insight for this solution. That's how I kind of figured it out. And the short answer for this problem is dynamic programming. I actually didn't implement this in a good way. And I will go over the code in a second. So basically, the idea is that in each state each state would be x, y on the coordinates, and also whether you need a negative number or not, right? And once you phrase that, it becomes a lot easier to understand and write the recurrence. That's how I always try to figure about it. But if you watch me solve this live during the contest, I actually struggled because I asked the wrong question a little bit. It wasn't clear in my head what the question was. And that's why, for these kind of problems, if you're trying to figure out the transition, you have to ask the solutions very precisely. Otherwise, you're going to have to mingle with off by ones and weird edge cases and weird base cases and so forth. So for this one, and also if I look at it again, I might have split into two functions. But basically, if negative, if I guess maybe, and also I should call this positive instead of negative. That may have been a little bit better. But if the input is positive, that means that we want the max positive answer from this call, right? If negative, it's actually technically non-negative, if you want to call it that, because you want to get the max, right? If negative, then we want the min negative answer from this call. I can't spell. And min negative answer means the max absolute answer. So that's kind of why I that way. And I probably could have simplified things a bit if I did it that way. But yeah. And then all it is after that is just going from left to right. I think one additional thing to note is that because the grid ij can only be up to 4. They don't tell you this, even though they ask you to mod. And also on JavaScript, it may be a little bit weird. So this is not true for JavaScript. So it's a little bit weird, to be honest. But for a lot of other languages, notice that it is up to 4 in the maximum value. And that rows column is equal to 15, meaning the longest path, it's only going to be about 29 or 30 even. And 4 to the 30 is equal to 2 to the 60. And 2 to the 60, of course, fits in a 64-bit int. Right, so those are the constraints that I would think about, and that's why you can mod it at the very end instead of like modding it progressively, which leads to other type of issues as well. Which in this problem you don't have to think about it, luckily. But yeah, so basically, once you have these questions, the transition becomes easier. For base cases, right? If you go out of bounds, if you want a negative answer, you want basically the opposite as a base case so that you never return this answer. Basically, this is a send value that should never happen. So you should return the positive infinity number, which I have this, but I should have really rewritten it. And I have the negative infinity answer instead, right? So let's actually maybe do a little bit in refactor. So let's return infinite, and this feels a little bit backward because you basically don't want this to ever be the answer you return unless there's no other choice. So that's why if you want a negative answer, you return the opposite of what you want. And then the other base case, and this is for if you go out of bounds, right? And the other base case is, let's say you get to the corner, if you want and again, this is where we can go back to the question, right? If we want the negative and the number that the number at the corner is negative, then we could just return the number, right? Or 0, I suppose, actually. But and I actually double checked during the contest. And if you want a positive answer and the grid number is positive, then you just return that value. Otherwise, again, this is the same as this, though it's written differently because I'm awkward. But yeah, and where I confused a little bit was that I actually initially, if you look at me during the contest, I solved it like this. But now that you have this recurrence, this becomes a little bit easier to reason, which is that, you know, basically if the grid answer, if the current grid value is negative, then we want to swap what we want, right? Because and we should have, this doesn't even, I don't know. I guess I should have combined these two things. So let's actually do that in retrospect. No, it's okay. But yeah, but basically if you want the negative answer, as we said, then we want the minimum negative answer. So we take the min of the current value times this function, which yeah, if this is negative, then it'll, you know, basically you want the minimum negative answer from this core, right? And if it is positive, you do the same except for max. So that's why the max and the min are different, and that's why the confusion here would not be great, because this is not what that's not your input, right? So you're returning a wrong input. So yeah, so that's pretty much the transition. And this transition of going bottom and to the right, there are a lot of Leetcode problems that deals with that kind of transition. So I definitely recommend you go for it. But basically, the question, recursion is, and dynamic programming and memorization is just rephrasing the question in a way that you can ask a different question by itself, which means that, okay, if I go down and I want a negative value, how do I go, right? Or like, what's the smallest negative value if I go down? And what's the smallest negative value when I go to the right, and so forth. So that's kind of the way that, so that's the kind of the answers that this would give us. So yeah, because if this is negative, we want our input to be the opposite of whatever, so that we kind of keep on alternating. So then at the very end, if this is greater than it's close to the infinite, my previous infinite value, then we return -1 for not possible, and then otherwise we just return the answer the mod value, and we kick off in the corner with asking for non-negative, so positive value. So what is the complexity here, right? Well, if you look at this function, everything we just do a constant amount of time, so this is going to be O of 1. And then now we look at so work per core is equal to O of 1. So how many possible inputs are there? Well, there's rows times columns, and negative it's 2, right? So number of possible cores is equal to rows times columns times 2 for positive and negative, so which is equal to O of R times C, or 15 squared in this case. So yeah, so that means that total work is equal to O of R times C, and of course, you can actually reduce the space a little bit more by noticing this only goes left. This only goes right and down. So you could rewrite it bottoms up with dynamic programming to even reduce the space complexity more. And the space, of course, in this case, is just the number of possible cores because we store one cell for each one. So this is time complexity, and space complexity is equal to O of 1 per core. And given that we have O of R times C core, this is equal to O of R C space complexity. And again, you can upsolve by converting this to bottoms up. And with that, you can upsolve more by using the space optimization technique. So I'll link below on that dynamic programming progression tutorial that I have. But in terms of explaining this problem, that's all I have. Let me know what you think. Hit the like button, hit the subscribe button, and you can watch me solve the problem live during the contest next, after I press the button. Thank you. I'm really behind, really slow today. Oh, sounds like it's annoying already. Also, yeah, I keep on forgetting about mods, so let's do that. Okay, and then now the status. Only one non-negative, so 0 is okay. So this fits in long, by the way. Maybe. This is annoying. positive answer. Let's see. Oh, what? This is an awkward one. A lot of potential issues here. That doesn't look right? Well, this is fine, but might have gotten signs wrong. That's not right. Should give me 100. That's not 100. My base case is pooped. We're looking for a day. No, this doesn't make sense. You're looking for a day. Okay. Okay. That's good, but that's not so good. Just this thing. makes sense, but why is that? So we're looking for this should be, huh? Oh yeah, it's still, no, this should be false. Yeah. Yeah, okay. It's just still wrong though. Oh my God. This code should be more right. What is this one? It should be just 325. So this is new negative is true. It goes here. This is true. We're looking for the true negative. But this other thing go here. This is still true. Did I mess up the signs again? New negative, right? So up. No, this should be, that's why. Oh, I think I'm mixing it up. Okay. Because it was negative then one. Okay. Okay. And this is fine because I probably need this to be bigger. That's unfortunate. Hey, yeah, so that was the end of me solving this problem during the contest. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord, ask me questions, let me know how you did, how you feel, and I will see you during the next problem. Bye-bye.